My name is Marlene Behrmann. I'm a professor in the Department of Psychology and the Neuroscience Institute at Carnegie Mellon University. There was a very particular series of events that convinced me absolutely. So I was trained as a speech pathologist, and I worked as a speech pathologist for about 5 years with a master's degree before I went into any PhD program. So I was really a clinician kind of on the ground. And I worked mostly with adults with aphasia, with communication disorders after a stroke. What struck me the most is that if I went from person A to person B to person C, they would have similar kinds of communication disorders. Like they would have the same pattern. I mean, we know this from the literature, but it's quite a different thing when you see this before you. So there's something so rule governed about the way the brain breaks down. So I was working with patients who have lost the ability to either recognize faces or objects after some kind of brain damage. So I was studying this one individual who sustained a head injury, mostly affecting his visual behavior. So in the beginning, I had to sort of survey the nature of the disorder. One of the things that was particularly interesting to me was to understand whether or not the failure to perceive input also affected the ability to imagine visual information sort of in the mind's eye. There may be dissociations between perception and imagery. And there is a lot of complexity in the literature about whether or not these two processes, sort of seeing in the world and seeing in one's mind's eye, are the same or different. Here is one quick example. So when individuals learn to read, there is a region in the left hemisphere, the so-called visual word form area, that is detectable. And it means that there is the circumscribed region that shows a much greater response in using functional MRI, for example, in response to words compared to pictures, for example. So this so-called visual word form area almost always emerges in the left hemisphere, which makes a lot of sense because for the majority of the population, language and speech are properties of the left hemisphere, and reading should be tied up into the language system. Now, if somebody doesn't have a left hemisphere, what is going to happen? Are they going to be able to read at all? Will they ever learn to decode print? And some of our studies are longitudinal. So we study the kids before surgery, and then after surgery, basically we scan them at 6-month intervals. And we've been able to show, and have still got some ongoing work, showing that the visual word form area can emerge in the right hemisphere of these individuals. So that's pretty dramatic, because something that is almost destined to be in the left hemisphere is now turning up in the right hemisphere. So there are many open questions. But there are demonstrations now that the brain is probably more resilient than we had previously thought. And I think this is where we can really work hard to understand resilience, to understand the principles of resilience, with the hope that we can use those to customize intervention and target therapies in the longer run. So at the actual induction, which is in Washington, D.C., there's sort of a big ceremony. I was motivated to try and communicate my science to people, and decided that I would make a dress that signaled kind of cognitive neuroscience. And so I scanned my brain, very high resolution, 3D structural scan, and then took the image and transferred it to fabric, which you can do these days, and it's not too difficult. And so this large bolt of brain fabric turned up at my front door. And I like to sew, so I sewed this dress, which really looked like a brain. I connected with a friend of mine in the drama department who makes costumes and does all kinds of weird and wonderful things. And we decided to sew LEDs onto the dress, and we hooked it up to an Arduino transformer, which I placed outside the dress on my hip. Typically, some women's dresses have got like a rosette or something on the hip as for decoration purposes, but I wanted to use the tech for decoration purposes. And then I had a microphone that was hidden in my collar. And so each time I spoke, it would drive the LED lights to be activated. And I only used lights like the legend that we use in functional MRI. So blue for low activation, all the way up to bright yellow for, burning activation. And so the dress would sort of randomly show one of these patterns of LEDs that were lighting up. And so I wore that, and some people really got it. And anybody who could recognize the brains, would give me like a thumbs up. But there was a case where somebody came to me and said, "Do you know that your dress is on fire?" And so it was a fun activity and an interesting take for me to really use the opportunity to portray what it is that I do. So I am somebody who changed careers. I was trained in a very particular field. I worked in that field, and somehow it didn't quite seem sufficiently engaging to me. And so I made a change. I went to graduate school. I was much older than the typical graduate student. I was not as good at calculus as they were. My programming skills weren't as good as their skills. But with some persistence and resilience, it turns out it's possible to do that. It's possible to learn a new field with a lot of work and a lot of commitment. And after that, graduate school was amazing. I just felt like I felt like my head was expanding every day. And the most wonderful aspect of both graduate school and having this kind of scientific career is that you can determine what your own interests are, and those interests can morph over time. I strongly encourage students to pursue their interests, but also to go into these fields with eyes wide open. It's not an easy road. The amount of work is, of course, infinite. It's hard. The pressure is huge. And one's so often subject to evaluation. You submit your paper, it's rejected. So I think there is personal resilience that needs to be built into this kind of career. But it is really balanced by, as I think about it, the thrill of the chase. Like, there is stuff to be discovered. There is stuff to be learned.